society is consuming more and more data with a massive number of wireless devices connected to the internet. Due to the uptake of Internet of Things, the carbon footprint caused by wireless communication keeps increasing. Battery disposal causes harm to the environment, and as the number of IoT devices grows, replacing the battery of each IoT device on Earth is not viable anymore. Scientists and engineers face the challenge of how to guarantee both prosperity and sustainable development and curb the carbon footprint of communication technologies. This goal is in line with the Sustainable Development Goals set by United Nations by 2030.
The objective of this project is to design a new paradigm of wireless communication where IoT devices without any battery are capable of harvesting energy sufficient to receive and transmit sense data autonomously. By doing so, we aim to make a significant contribution to the goal of removing batteries from mobile communication. From a scientific point of view, we aim to solve the fundamental roadblock that currently impedes the vision of battery-free devices. And we do so through the convergence of two main technologies, Li-Fi and passive RF backscatter. The first technology is Li-Fi. Li-Fi is lately considered as a sustainable technology to guarantee rapid connection to internet. Li-Fi uses light bulb for communication, and the LEDs in the bulb are modulated quickly to transmit information through light, so quick that our eyes cannot see any change. Instead, a photodetector can distinguish this light variation and then receive data. The second technology is passive RF backscatter. Passive RF backscatter works by reflecting and modulating any ambient RF signal received by the IoT device itself. Data sensed by the IoT device is transmitted through energy efficient solution to a RF receiver. At home, this RF receiver could be integrated with a traditional Wi-Fi router that is used for providing wireless internet connectivity. As a result of merging Li-Fi and passive RF backscatter, we are enabling the creation of battery-free IoT devices.
In this first prototype, Li-Fi transmitter serves as a source of energy that the IoT device is able to harvest, and as a source of data to communicate to the IoT device. The IoT device captures the energy from the light thanks to a solar cell. The solar cell works as a photodetector, and we use it to store energy and receive data from the Li-Fi transmitter. The IoT device uses the RF backscatter technology to transmit any sensed data to a receiver connected to the internet.
This picture shows the main components of the setup. As Li-Fi transmitter, we use and customize our OpenVLC platform to control the illumination of the light. The IoT device contains a harvester to capture as much energy as possible from light, a VLC receiver built with an integrated solar cell and a comparator, a low-power microcontroller to process Li-Fi received signals, to trigger sensor activity, and to control the oscillator in the backscatter circuitry, and the backscatter circuitry that is responsible of reflecting incoming RF signals with its corresponding modulation. The RF carrier generator can use any ambient RF source or being integrated in any off-the-shelf RF device. In this experiment, we are using an external device. Finally, as RF receiver and as a central controller, we are using software-defined radio for prototyping.
This project enables multiple IoT applications. For instance, this could be applied to greenhouses, where IoT devices could be deployed for monitoring and controlling the growth of plants, and to home automation applications in smart homes. We hope that this technology will significantly contribute to revolutionize the blooming IoT market by avoiding the use of batteries for communication.